So I'm gonna be teaching you what I've learned my first few weeks in calculus,
Okay.
and we've been going over graphs a lot and like the relationship between distance and velocity.
Okay. So
So,
what is the, I know what distance is. What is the definition for velocity?
we like came up with a definition that velocity is speed in a certain direction. So whether it's like positive or negative velocity,
Okay.
and then the average velocity like mathematical equation I guess is like displacement or like distance over time.
Okay.
So then, if you multiply the time to both sides, then average velocity times time equals displacement or the distance. So then, with that equation, we can find the distance of, we can find the distance on a velocity graph. So if we have a graph like this, where this is the time,
Okay.
and then this is the velocity. Um, yeah, 8, 12. So if this is the velocity, then we're able to do right here. So like I said, time times average velocity, so 2 times 4.
Okay.
Well, like see, we're using the triangle shapes, then 2 times 4 equals 8, and then times 1/2 equals 4. So then the area underneath this this area right here
Yep.
is 4, and so then that's the distance that you traveled within the 2 seconds.
Okay.
And then the other way, we were trying to find velocity using a distance graph. So we have the distance graph, and then say, yeah, one. So this is the time again,
Okay.
but then right here is the distance instead.
Okay.
So say like 4, 8, 12. So like say it's just feet, and then these are seconds.
Okay.
So for the distance graph, the slope of the curve, or in this case the straight line, equals velocity.
Okay.
I mean that's because when we use this equation up here, so average velocity equals distance over time. So that's basically just rise over run, which is the slope formula.
Okay.
So say we just go up 4 divided by 1, so then the slope is 4.
Yep.
And then again 8 divided by 2 equals 4. So then in this the slope is 4, so then the velocity is 4.
Okay.
Alright, explain this for a third time since the storage on the phone didn't catch it again, but So here we're looking at, no, that's the wrong side. The distance and then the velocity curves.
Okay.
So, I was trying to say earlier, it's a velocity, speed in a certain direction,
Mm-hmm.
and then we're using distance because it's a more common term, but it's more like displacement. So it's how far you are from an object. So I'll just use an example as a car. So if this is the starting point,
Yep.
and so if we say we go this far back,
Yep.
we're like negative 10 feet from,
The starting point.
yeah,
Yeah.
and then here, we're 10 feet from the starting point,
Yep.
and that's why,
Positive.
yeah,
Yeah.
positive. And then that's why as, Luna, stop. That's why as we're approaching here, I was saying, so if we do another graph, where if we start back
Mm-hmm.
10 feet, negative 10 feet, that's where, as we're approaching here,
Yep.
we're approaching to 0, and then the velocity, it's negative, approaching to 0,
Yep.
and then they get there, and then it's positive, so that's why then the arc goes up.
Okay.
And then also, it doesn't need to be like these perfect curves either. It can be like, the velocity can be all curvy,
Okay.
like this.
Yep.
Like I said, it doesn't have to be the constant, because that's
Not real life.
not realistic in real life. And then this can just be like that also.
Okay.
So yeah.
All right. That helped a lot because I really didn't understand the negative distance well.
And then I guess just to put this in summary, like where we like actually able to apply this to real life. Like the first thing we did, we went on like a drive for like just an hour, and we took the speed every 3 minutes, and then afterwards we had to try and figure out how far we drove,
Mm-hmm.
and like the accurate way to find it was we did like the graphs to say like every 3 minutes. I'm just gonna do like 9, 15,
Mm-hmm.
and then be like 27. So like we did here 27, and to say it's like 30. So we go up a little more. Then this one just happened to be 15. I don't know. So then we did what we figured out earlier. We find the distance underneath the velocity curve, and then it's cool because we drove for an hour, and then we were able to figure out the distance we traveled just by finding random times or random speed at random times. So I guess that's a way to apply it in real life.
Okay. So this was the intervals, the
Yeah, this was
minute
the
intervals.
yeah, the time.
And this was the speed that you were traveling?
Yeah.
Okay. All right.
So I mean, obviously there's a lot more values.
Yep.
But yeah.
Okay, that's cool. All right, thanks.